Hi Science 10. In this video, we'll be looking at greenhouse gases in the atmosphere. Specifically, and you can see it behind me, you can see some clouds there, and of course, I'm standing in it, breathing it. The atmosphere traps heat here on Earth. If we compare the Earth and the Moon, they're actually very close to the Sun, very similar distance from the Sun. And yet the Moon is not at all like the Earth. It's lacking in atmosphere. And one of the key things that the atmosphere does for the Earth is it provides an ability to trap heat and gives us our climate. So that's specifically what we're going to be looking at in this video, is greenhouse gases in the atmosphere and the environment. We're going to start with how greenhouse gases trap heat, and we're going to see what some of those greenhouse gases are. Okay, let's see that next. So we're going to look at how greenhouse gases trap heat. In fact, water vapor is actually the biggest greenhouse gas in our atmosphere, has the greatest effect. Now, the thing about water vapor, it's of course natural. It's not due to human activity. And in fact, as soon as water vapor goes up in the atmosphere, it comes down. So it's at a very constant level. It really doesn't change. But these greenhouse gases here in this list do change. You need to know each of these greenhouse gases, their names and their formula. But I wanted to talk a little bit about and why water vapor and also carbon dioxide, which is the one there on the list, why greenhouse gases are very good at trapping heat. If I put my hand here, this is very, very hot, and that's from the water vapor. Water vapor and water is very good at trapping heat. Well, so is carbon dioxide. In fact, so are all of these on the list. And here's the reason. If you look at the water molecule, and if you look at the carbon dioxide molecule, and of course, we know that this is one carbon, two oxygens. This is two hydrogens, one oxygen. So if we look at the formula, we also know what the structure of the molecule is. As these molecules heat up, these bonds here actually start to vibrate. And they vibrate for a long, long time. And ultimately, that's what's going on with this water right here. There's, trillions and trillions and billions and trillions of water molecules in there. They're all heated up and they're just vibrating. The bond right here is vibrating and they'll continue to vibrate. Now, of course, eventually it'll cool off and it'll basically end up being the same temperature as the room here. But right now it's going to hold its heat for a very long time and it's letting water vapor up into the atmosphere in this room right now. So yeah, to kind of recap, the key information right now that we're learning is greenhouse gases do trap heat. That is why we have a climate here on Earth. That's why it's not like the Moon. But specifically, it's these gases in the list here. This is what's giving our atmosphere its ability to trap heat. Natural from water vapor, but all of these are in our atmosphere primarily because of human activity. Now, of course, carbon dioxide could also come to the atmosphere from natural activity, from forest fires. Methane can actually come just from decay of dead material. Again, can be natural, but in very small amounts naturally. These are being put into our atmosphere excessively by burning fossil fuels primarily, but also from farming and other industrial activities. Carbon dioxide, methane. This is called nitrous oxide or dinitrogen monoxide. And these are chlorofluorocarbons. We find these in refrigerants. They actually help keep our refrigerators cool. And these are the primary greenhouse gases emitted by human activity. Again, you need to know their name, you need to know their formula, and you need to understand how they're trapping that heat. And it's because of as carbon dioxide heats up, the oxygen molecules that are bonded here, they just start to kind of waver back and forth. And essentially, they just keep waving like that for quite a while. Same way that this pot of water takes a while to cool off. Eventually, it will. All right. Next, what we're going to look at, we're going to actually look at the atmosphere. And we're going to see, what is in our atmosphere? How much of these greenhouse gases? So let's take a look at that next. All right, so now we're going to look at our atmosphere. This is a model of our atmosphere. Ultimately, our atmosphere is absolutely massive. But what I'm going to use this measuring cup to show you the proportion of gases that are in our atmosphere. Now, primarily, about 80% of our atmosphere is made up of nitrogen. So we'll use this to represent all of the nitrogen in our atmosphere. That would be about
Actually, it's about 78%, so I'm pretty close here. 4 out of 5 is about 78%. So about 78% of our atmosphere is indeed made up of nitrogen. The next 20%, about 21%. So you got 78% nitrogen gas. The next 21% is oxygen. Oh, that stuff. So let's use this to represent the oxygen. There we go. Now there's just a little bit of a 1% left over, essentially, and that's all the other gases. Now, something to tell you about nitrogen gas and oxygen gas. First of all, nitrogen gas is N2 and oxygen gas is O2. And I want to show you a model of both of those. So there's nitrogen gas, there's the oxygen gas. And so ultimately you'll notice that they do look a little different, say, than carbon dioxide. The bond here doesn't start to oscillate or move up and down as it's heated up. Remember how carbon dioxide, as it's heated, the bond between the oxygen and the carbon, those two bonds, they start to basically wobble, and essentially it starts holding heat. It holds heat very well. These, nitrogen gas, oxygen gas, cannot hold heat at all. And so really the greenhouse effect, the fact that the atmosphere traps heat, is primarily from water vapor, natural, but human activity is causing a change. We're adding a lot more of these gases to the atmosphere, and these gases all do indeed trap heat. In fact, some of them trap heat very, very well. The problem with carbon dioxide is we're adding an awful lot of it. So I'm going to use this little dropper here just to represent the rest of the atmosphere. And in some of that part there, and it's going to kind of sink to the bottom, some of that part is, of course, carbon dioxide. So kind of it's dark in color just to represent the color of carbon. Kind of gives you a sense. It's not very much, but also this is why that amount can change very easily, because it's so small, it can be changed very easily. And a reminder that our heat in the atmosphere is because of all of these gases. It isn't from the nitrogen gas. That doesn't have any properties of holding heat. It isn't from oxygen gas. That has no way to hold heat. It is indeed these greenhouse gases that hold heat. Let's just show you the water vapor here. So again, we'll have a little bit of water vapor. Yeah, it's kind of steaming a little bit. So that would be the clouds in the atmosphere. And yeah, sure, they're natural, but that's very constant, never really ever changing the amount of water vapor. These greenhouse gases from human activity do indeed change. So we're going to look at next at how powerful each of these greenhouse gases that are emitted in the atmosphere from human activity, we're going to look at how powerful each of these are next. So as mentioned, greenhouse gases trap heat. Trap heat actually kind of like how a blanket traps heat. If you think about it, the moon, yeah, is just as close to the sun as the earth, and yet it's either super, super hot, literally 100 degrees, or if there's no sunlight, it's about 200 degrees below zero. So it has no atmosphere to trap heat and to moderate the temperature, to create a climate. So much like a blanket, so let's take a look. Much like a blanket, greenhouse gases, and there's, the major ones from human activity. We've mentioned how water vapor actually is the biggest greenhouse gas, but it's the amount of water vapor never changes, and it's always going up into the atmosphere and coming back down. So it's always cycling. It stays very constant. These are increasing, well, every day. Now, much like a blanket, some blankets are better than others. And you'll notice each of these blankets, well, is a little bit different, maybe is a little bit better. Carbon dioxide, it turns out, actually is the worst at trapping heat. Followed by methane. Methane is about 36 times better at trapping heat than carbon dioxide. And dinitrogen monoxide right here is actually about 300 times better at trapping heat. And these chlorofluorocarbons, some of them are tens of thousands of times better at trapping heat. Okay, so carbon dioxide, though, is the biggest problem. Now, isn't that interesting? Well, the reason is because
It's not just one little towel. We are putting lots and lots of carbon dioxide into the atmosphere. And it's the one that comes from burning fossil fuels, from running our modern economy, from running planes, trains, automobiles. Also, a lot of carbon dioxide is released from farming and from many human activities. So there you have it. There is the difference between the greenhouse gases. Some of them are better at trapping heat. It's just that there's, compared to carbon dioxide, there's very little methane in the atmosphere, luckily, and very little dinitrogen monoxide in our atmosphere. Okay, take care, Science 10. That is how greenhouse gases trap heat and give us our climate.